Hi there! Today we are going to talk about KiCAD HTTP libraries. I was trying to research the topic and I figured there is literally nothing on YouTube on that topic. So today we will set up the server, we will use PartDB application for hosting the HTTP library, we will connect it to KiCAD, and I will walk you through the entire setup. The most complicated thing here in this setup is you have to have a server. So you have to have somewhere where you're hosting your library where your KiCAD can connect to via HTTP. You can skip through timestamps. I'm going to show you full installation procedure. After we set it up, your KiCAD library experience is going to look something like this, where you have your fully specified components with the manufacturer part number linked to your supplier of your choice. In this case, it's Digikey, prices, and full specification, including the link to the datasheet. And adding a component like that is a matter of a few clicks, which is the most interesting piece of it. So as I said, to have the HTTP library, you have to have a server. The official documentation is describing the protocol. It is not optimal at the moment, and I think it will be updated, but we will get to this in the later parts of the video. And you will need an application that you run onto that server. And here is the project you probably heard about. It's called Inventory. It's an inventory manager. It's a very complex software that is quite mature at this point. But in my impression, it's not all that targeted at electronics. It's more generic. So I had to create all the category structure myself. Then you need a separate plugin to connect to KiCAD. Then you need another side application to allow you to create part from Digikey using API. So it's kind of, you need to tinker with it to get it to do what you want. But it is the most mature from everything out there that I saw. But the project we're going to be talking about today is PartDB. So it's this one. And I kind of like it. It has data integration with component sellers like Digikey and Mouser built in. And it's just created, it feels like it's created for electronics. I like it a lot. And today we're going to be installing this using Docker. So again, if you don't know stuff with servers, don't worry, just follow my footsteps. You will only need a computer or VPS server like Heroku, maybe Hetzner, Hostinger, whatever, to set up a server for yourself, and then you should be able to connect to it. Oh, there is a side note. I'm running everything on a separate Windows VM for demonstration to isolate it from my actual working environment, and you might find it laggy. I find it laggy too. I just wanted to have a clean environment to show you everything, not within my actual computer. At the end of the video, we're going to briefly talk about the Datasheets.md service. This is an application that we develop with friends. It also allows to connect to library. So it can also allow to specify symbol and footprint and then fully specified parameters. The main feature is that you can see where the parameter is taken from, but we will take a look at that at the end of the video. I'm just looking for people to give feedback on that. Okay, so let's get started, and we will start with setting up the Ubuntu server. Okay, so you'll need to have a computer connected to the internet. It can be anything, can be a Raspberry Pi, your old computer, your old laptop that is just always connected to the internet. And here I'm using a virtual machine, actually, hosting it in Proxmox, but for you it can be just a computer. And this is what you see when you just plug in the USB stick with Ubuntu installer. So it's a Ubuntu server, latest stable version. And I'm going to walk you through an install. It's supposed to be incredibly easy. So we just pick the language. It's an Ubuntu server. It has an internet. Okay, I just have it connected with Ethernet jack to my router. I don't need a proxy address. Okay, press done again. Use an entire disk. Again, just keep defaults. Done. Again, we can just leave it on default and we can adjust the disk size later. Yes, and I'm okay with losing all the data on the disk. So enter my data, my server name, let's call it KiCAD, username KiCAD, and whatever password. And we're done. We are skipping Ubuntu Pro. And we will need an SSH. It's good to have it. We don't need to authorize any key. We don't need any additional packages. And that's it. So we're installing a Linux server now. Okay, installation is complete. And now we can just reboot the computer. Okay, so I unmounted the installation media, like USB stick with Ubuntu ISO. And now it's booting for the first time. So we log in with our super strong password. KiCAD is the name, and now the password. And we are in the terminal. Okay, so we could have installed the entire PartDB application via the terminal, but it would be more convenient if we can copy and paste stuff. So we will do that via SSH connection through our main computer. To do that, we only need to know the IP address of the server that we just installed. I cleaned the terminal with the clear command, so now it's empty. And I do a simple command IP spacebar A. This gives me an IP address of my machine within my network. So that would be this one. And now I can switch to my main computer, the Windows PC, and connect to that terminal via SSH. Okay, I'm at the Windows PC now, and I still need terminal. So we type cmd, command prompt, and I want to connect via SSH to the Ubuntu server that I just created. So I'm going to type SSH, my username, and my IP address that I just checked. Okay, so we confirm that it's us, and we type the password. And now we're in. We are again in the same terminal where we just have been in the Ubuntu server. But now we have the advantage of being able to copy and paste into that terminal. So first thing first, once you set up the Ubuntu server, you always need to do updates of packages. So you do sudo apt update and password again. And then you need to upgrade the packages. So sudo apt upgrade. I just did it before, so nothing for me. For you, it will install all the latest packages. That's something you always need to do on the latest Ubuntu server. Okay, let's move to the next part. Now we need to install Docker and Portainer onto that server. So just to install Docker, I always use a GitHub convenience script. So I go to GitHub from Docker, official one, and I just copy that script over, Control-C. I paste that in the terminal using the right-click, right mouse button. And now to install it, we will need root permissions. So we will type sudo and then this shell command. This would install Docker for you. I already had it installed, so for me, I will cancel it. But this script is a single thing you need to do to have Docker installed. Now, next thing we need to do is installing Portainer. So we go Portainer, install, and what we need is Portainer Community Edition. So we click on install Portainer CE with Docker on Linux, and we need to copy two more commands. We need to create Docker volume. Yeah, I just created the volume, and now we need single command to run the Portainer. Now, from this point on, we will be able to leave the terminal alone and use graphical user interfaces. So executing this command is installing the Portainer, and this is going to be our GUI for dealing with whatever we want to host on our server. For those who just joining, who already had everything installed, now we are moving on to installing the PartDB, and we are going to use installation using Docker. And Docker Compose is what we're interested in. So remember, this terminal is our Linux machine, so it's something other from the computer that we are running. It's just in the same network. So to now connect to Portainer, we need the same IP address of that Linux server, and then semicolon 9443. And I need to change it to HTTPS, otherwise it won't work. I made a typo in the IP address. Okay, now it's good, and it will say warning that this HTTP is not actually secured with SSL certificate. It's within our home network, so we don't care, and we can continue. And now it will ask us to create an admin account. So just type password. Now it's good. And now we can get started and select our Docker environment. So Portainer lets you manage Docker containers. You can see it shows itself running. And here we can have multiple other applications running on our server in the background, and we have this nice graphical user interface to access it from our host machine, right? So that's kind of convenient. And now let's get to installing the PartDB. So we have this installation page, and here is the Docker Compose. This first is assuming that you have SQL running somewhere, and I don't really want to do that. I want to use this second Docker Compose, which has database as a separate container. So this file will spin up two containers for us, one for PartDB application and another one for the database itself. So I'm just going to copy it as is in full, copy, and now I can create a stack. So stack is something in Docker to manage containers, right? So I'm putting a stack over here, and now port 8080. Yeah, this port is empty, but this is the port at which you're going to access the app. You can see here, I'm accessing this one at 9443, and I think another one that Portainer is using is 8000. So 8080 is free, but if you have something else installed, it may be conflict, so you would adjust here. And storage folders you can keep as is. Change the password for the database. So here is the secret root password and secret user password. So secret user password is something that you would want to change. So for now, let me just do secret user password 1, which is very secret. You can hack that in a minute. But I changed that as developer has suggested. And I think that's all we need. So from the rest of the compose file, I don't think we need anything. So we need to type the name of it. It's going to be PartDB. And this is the stack we're going to run. So let's deploy the stack. Okay, and our stack is deployed. So now we have our own server that is running the PartDB instance. Now to access it, we are going to go to the port that you can see two containers, so database container and PartDB container. And to access, we need to go to that port of the same server. If you are not in your home network, you are away in the office elsewhere. So you can then set up this service and connect to your database from remote locations. We will do that later in the video. So for now, we want to try to access it from our internal network. I'm just copying this entire address and I'm pasting that in. It's not HTTPS anymore, it's HTTP and 8080. And here we should expect our PartDB instance. And it says internal server error, which is expected. It is expecting us to migrate the database. So this is something I forgot to do. Let me see, where was it written? yeah, this is the command we need. So this is the command to migrate the database. It needs to be executed from the console. So we get back to the shell, and now we already have our containers running. Now we can migrate the database. So let me copy that again and paste that in. Okay, it's migrating, and now we will need to watch out for the output. It says the password is, and it gives us the initial password. So this is something to look for, and we need to copy that. All right, and it says that successfully migrated. Now if I refresh the page, it now works. All right, so now I can just notice that you can access the service without logging in. It has certain permission system, and you can set what permissions are allowed for not logged in user. So for the first login, we do admin and password that we just copied. We may remember me. And it will immediately ask to change user data. So we can keep it as admin. I think I'll change to KiCAD to be consistent. And here it will not let us go anywhere until we change the password. So I'm going to change the password here and repeat the password. Oh, sorry, that needed to be the old one. So I paste that in, and then the new one is, and repeat, and apply changes. Now we are admin with a new password. And so let's start the tour through the PartDB tool. First thing, we need to set up categories, edit categories. This editor menu allows something like mass creation. So for me to import all my categories the way I want to have parts organized is just copying the list and pasting the list. That is quite amazing. So this is the structure of the library I'm used to using. And I'm just going to create that. And now I have my library structure in, which is amazing. I love it a lot. And now we can start creating components. But what is great about this particular tool, it has something called create part from the info provider. So this is one of the reasons I'm recording this video. I think this is incredible, and I wanted to show this to you. So here, it's all disabled at the moment, but you can connect to any of your suppliers, and I'm going to go with Digikey. You are connecting its API, and it allows you to pull the part data from the Digikey. Things like parameters, cost, data sheet, whenever you create a new part. So to log in, you would need to go to Digikey. All right, now I logged in, and you will start, I think, from the home page. So this is going to be the page where you're landing in Digikey once you log in. What you need to do is you go to organizations, and from that page you create an organization, and that would give you possibility to create a production app. So you are creating the production app, and from there you can get an API key. So let me make another one just to show you. I'll enter the app name KiCAD, and I want to enable all of the APIs. Digikey allows you to use their APIs up to 1,000 requests per day. So this ordering is not available, but that's okay. We don't need the callback, I think. And reference API. Okay, and we create the production app. Open it up, and from here we can copy the client ID and client secret. So this is what we need to activate it within PartDB. We're going to copy over the client ID, paste that in, and copy the client secret and paste that in. I would select US dollars. Okay, I apply changes. So we go again to create parts from info provider and available providers. And now we can click on Digikey, connect with auth. And it's connected successfully. So now we can actually create a part using Digikey as an information provider. So let's just get any part. So now once we want to create a component and we know its part number, we just copy it and we go, oh, we don't need this anymore. We don't need this at the moment. We can close that. So we just copy it, paste it here, and search. This will search Digikey, and you can see it's rather quick. We want cut tape, and I want to add this component. It will not pick up the category because we have a different list of categories compared to Digikey, but it will suggest which category it was on the Digikey website. For me, it's going to be passive, but at Digikey, you can see what it was. And it has its own footprints database. I'm not going to use that. But what I'm going to use is EDA information, and I'm going to say it's a resistor. And we can here select the symbol and footprint from the KiCAD standard library, or we can create our own symbol and footprint, call it that name, and then put that name in here. So here I'm going to use device R, which is a standard symbol for resistor. And for the package, let me just type 2512. It's going to be resistor 2512. And like that, we have created a part into our parts management system, which is also able to track inventory, and it has tools for label generation and scanning. That has all the Digikey information. You can see all of the parameters are there. It has an attachment, so you can open the datasheet just by clicking it. Here you go. And you have the pricing information. And all of that is now going to be available in your KiCAD library. Okay, so we're switching to the next part of the video, and here we are going to connect our PartDB database with. Okay, I have opened KiCAD. Let's create a new mock project just for this experiment. And I'm going to put it in my documents. I'm going to call it tutorial. We have a new project. Now we have access to Library Manager. By default, I'm going to use a standard set of libraries because this is where we are getting the symbols from, but I don't want to have them visible, so I'm going to select all and deselect visibility. And now we need to create our HTTP library, right? So let's go to the project location, and we need to create a new library file. So I'm going to get back, create a folder, call it HTTP lib. But this is just a folder, it's not important. What is important is when we follow the manual, we need to create this kind of library part, a library file. Paste that here and save as. And this is the format name extension that we need to use. Save. Okay, we have our library. Now, to actually be able to connect to it, we need to have root URL changed, and we need to generate the token. The rest can stay the same. So the root URL would be the address of the library here. It can be HTTP, it can be HTTPS. To make your library HTTPS and publicly available, you can use Cloudflare tunnels. It's a free service, and I tested it, it works. But for this tutorial, to make it shorter and simpler, we're just going to replace this piece with our local area network IP address. So we leave this piece with English and KiCAD API, and now we need to generate the token. And this is a little bit tricky. So you first need to go to the system settings, if I remember correctly. And let me see. Okay, we go to users, and we find us, which is an admin, and we go to our permissions, and surprisingly, admin doesn't have permission to API by default, so we need to change that first. We save it, and now we can create API key from our personal settings. So it's going to be user settings, and we're going to scroll down. This menu is not available if you don't change the permissions, and now we create a new API token. I call it KiCAD, and we create the token. So I can copy it here and paste that into my text file. Save it, close it. Now we need to add this text file as a library to KiCAD. So I'm going to use that same path that I just used here, slash, and the file name, and I'm going to call it PartDB. Enter. We need to show file name extensions. Yes, that's the notepad. So we have to not trust Microsoft stuff and use something else, but for now it's fine. I just removed the TXT extension from it. This KiCAD HTTP lib, it doesn't mean anything, it's still a plain text file, but in order for library to work, it needs to be like that. Okay, so now it's supposed to connect, and you'll notice it's not very fast. Now I can open the schematic. Okay, and we have the library loaded. And we can see our resistor here. If I click on it, it loads the symbol and footprint and all the properties. But this is yet another limitation of the HTTP library the way it is right now. It is only loading the component information once you click on the component. They did it to save bandwidth, and this is the way their API is built. But this is causing an issue that, for me, a showstopper. You have all of the properties like manufacturer part number and Digikey part number, and you can have more properties over here, but they are not going to be shown in the component selector, because at the moment when you open the component selector, these properties are not loaded. You can see if you place the part and its metadata is currently saved in the buffer, it will now appear under recently used. So here, these properties are loaded in this instance, but they won't be loaded in the library. So still, if you don't want to use these extra properties, you can absolutely manage your library from the PartsDB server and have it connected to your KiCAD instance. Okay, so to fix this issue with HTTP libraries, that they are not loading all the parameters on time to show in the symbol chooser, and they also kind of slow, I want to use a workaround and have a local database library that is being synced in the background with the PartsDB database. So PartsDB application rather. I want to clone my own repo that I made for this. It was vibe coded, nothing important, so like take it with a grain of salt. I call it PartDB, let me see, ODBC sync. So you just open the GitHub and make search, you'll find it. It's a public repo with permissive license, and it's just 2 scripts. So one of them will create a database library. It's going to be SQLite, and another one is going to be syncing it. So whenever you made a change here, over the HTTP it will appear immediately. Over the database library you'll need to refresh it. But I think the result is worth it, so let's do that. To get the repo, we need to clone the repository. If you're not familiar, it's most convenient to install the GitHub desktop. You will need to have an account. Then you just copy the URL and you open the GitHub desktop and you say clone the repo from URL, and you paste that in and you have it. Okay, now we can show it in Explorer. And let's look through README. We will have to have ODBC driver on the system. So ODBC is a technology for database connection. I think you may know this better than I do, but it's basically a driver that we need to get for the light SQL. For Windows, it's going to be this one, and we just need to install it. This will install a driver on the system, and we can also install SQLite 2, but I think the one we use is SQLite 3. Okay, so we have a driver now, and we need to make a config file. Now, server URL, we can basically copy all of it from our GitHub library, our KiCAD library configuration, the HTTP library config. Okay, so here I can take the URL and the token. So I'm going to save this config and let's move forward. So now we can just run the sync. Let me see. We need terminal open in the window with this Python file to run Python from the terminal. So to do that, let's get back to the folder and open the CMD in here, CMD. And now I'm going to just paste that command and hope that I have Python installed. I pasted too much. I just need to save it this way and try that again. Okay, now we're good. Now reopen Symbol Chooser in KiCAD to see updates. So now we have SQLite file, library file, and we have KiCAD DBL file. We can edit that too. So inside it specifies categories that we want to show in KiCAD for every category. So we have here passives, and I think that's all, right? So my PartDB only have one category filled in at the moment, so we have only one of them. And you can see there is quite a bit of properties involved. So you can remove the ones that you don't want to see in KiCAD, modify this file, save it, and it's gonna work. So now if we are getting back here and we select that library, so I paste the path, then slash, and then the KiCAD library definition file. So we get back to the schematic capture, and here you go, our database library. And here you can notice that we have more properties. Digikey SPN is not filled because the script now calls it different. It's now after the script processing. Let me see, it's a supplier part number. So it's just a matter of script. You can just ask your AI to modify it. So here is the Digikey part number. You can see that in the symbol chooser. And you can also see, let's say that's a resistor. So you can make your selection experience much better by having a resistance value, for example, shown. Okay, it should show the same. Yeah, value is what I type in the PartDB, and the resistance is what it captured from the Digikey. So we can use either of those. And so you can see this is a full legit library now. Here in the item, we can use internal part number. I don't have internal part numbers set up with PartDB. You can do that. And once you place your component on the schematic, it keeps all the metadata. And you have all of these data from Digikey inside. And as I said before, you can choose what data you want to see with this database library config file. But it's all available to you, so it's now you choosing. And also the price. So price per 1,000 devices. It's actually one of the reasons why I wanted this. I wanted, when I'm selecting a component, to see the prices So let me also include that column now. So now this is my component selection experience. That would be all. It was very tense. At the end of the video, I just want to show you one more thing. It's a service that we are building with my friends, and it's called Datasheets.md. Let me sign into my account. So registration is open. You can make an account for yourself. And what I'm aiming here with this project is to make a public library. So at the moment, there is like a homepage. It's very, very raw. Sorry for that. But I'm looking for help with testing and improving this system. Basically, on the homepage, you have public parts. It's not many at the moment. You can open it up. And part is created mostly based on its datasheet. So to create a part, you're uploading its datasheet. It's stored then in the system. We are parsing the datasheet and what's inside of it. And we have a bit sophisticated parameters extraction system. So we have a preset of parameters, and we extract the actual values from the datasheet in a way that you can check where it's been extracted from. So the value where you have this icon, you just click on it, and the system will tell you where it's taken the value from. You can see on the right, this is the same info from Digikey, so the same API that PartDB is using. And you have possibility to add parts to your library. So here, this part is already in my library. And then once you do that, you can modify values. So let's say the model made a mistake and it's actually not ±8. So you can add it. That's going to be correct in your library. And you can add symbol and footprint for KiCAD or any other HTTP-enabled EDA software. So I imagine if you use Altium, you would use HTTP REST API that our service provides, and then a script similar to this to make it local to your machine and use it with ODBC. So at the moment, we are not making symbols and footprints. We rely on existing ones, same way that PartDB is doing. So you need to enter the name for the symbol. But we will work on that. We may connect to existing providers of CAD data, like SnapEDA, maybe something like that. But most importantly, I just want feedback. So here, we are working on making all these parameters available via API. So it's the same as you can get from Digikey. The only difference is here you get every single parameter. So it's not like you can access just a number like here, continuous drain current, but you can get minimal, typical, maximum value for all parameters from every cell in the datasheet. And whenever you want, you just click and you see the source where it's been taken from. So I find this valuable. I think this can enable next generation of design software, because having these parameters locked into the datasheet, it's not the best thing in the world. And having that centralized database that also has the REST API for symbols and footprint may make it the library of the world. So I really believe in that project, but it's eventually up to users to decide is it useful or not. So if you just want to get in touch, just contact me. So if you get to upgrade your plan page, we are just letting you parse 10 documents because we pay for parsing the documents. If you want unlimited, then we need to enable your admin permission. So just get here, contact me, or create an issue on the GitHub repo and help us build this forward. I have just added several more resistors to show you how to update the library. So the local database entry, right? So we need to open the terminal again, and let's go for the description. So that would be running the sync. Okay, new parts have been added. And now it's asking to reopen the symbol chooser, but in reality, we need to close and open entire KiCAD. This is yet another limitation that can only be fixed if we fund the founding team better and somebody actually gets to develop it. You need to close fully and then go KiCAD, open it up, and now it will load updated libraries. And since we have connected both HTTP library and the database library, when we open it, we will see both and we will see the difference. Okay, so it's loaded and you can see having a local database gives you all the properties in a symbol chooser, but if you click on the HTTP library entry, it will think for a while and then it will load the actual properties down below. So let me expand it. So you can see HTTP library is not that much worse. It also has all of the data in it. So if you generate the bill of materials, it will be good. It just doesn't let you see this in the symbol chooser. I figured in many cases you would be not accessing your part server from the same network as your computer, and I better show you the VPN installation. It's rather easy. So when I click login, I just pick my GitHub credentials, and now, okay, and my server is Linux. So to install it, I just need a single script like that, but then it would also redirect me for logging in. So even if you want to, if you're planning to use VPN on your server, I would recommend you first log in with SSH within your local network so that you are able to copy and paste stuff. Okay, and now I can install the Tailscale client. Okay, it installed itself, and the last command we need to execute is sudo tailscale up. Now to authenticate the app, we need to copy this, so right click and connect the device. Okay, now it's there, and we need to download it for Windows. So we run the app and it's triggering the connection in the browser. We connect the second device, login successful, and now we can get to admin console. And you can see that in my particular network, this is very private to me. So if you try to open this IP address, you will see nothing. My host machine, this is my Windows machine, has this IP address, and my KiCAD server has this IP address. And so now I can connect, for example, by SSH with this IP address. If I exit, is it? Yes, I can do SSH again, my login at that new IP address. And yes, it's a new connection, but it will be recognized. And here we go, we are in terminal within our virtual private network with the very private tunnel. And now all the apps that are running, like Portainer and this inventory manager app, they will be equally accessible at this new IP address. So you can see, right, you need to log in again. So, okay, and here we are. So you would just need to change the IP address in your HTTP configuration of your KiCAD library or in the script if you decide to run the database library, and that would allow you to access your server remotely, be it a computer, Raspberry Pi, or what have you. One more thing I wanted to show you is advanced features of PartDB software. You can see it has full logging, so it tracks every single action anyone performed. And I really like the permission system here. So you can make user groups and give permissions to groups. Permission system is quite advanced. and you can give permissions to individual users. So basically you can have a group of librarian with certain access, group of people who can just view your database, and like admins who can do everything and like create API keys. And then every action would be still trackable. So you go to your part, and if somebody changed the footprint or something like that, you would just go to the history and you see what happened, the full event history for every part. I think this is quite advanced, even though the creator says that the software is not good for production use, so there might be some issues with it. I haven't found any so far. Let me know your experience with this app if you're going to use it moving forward. I think I'm going to. I would definitely give it a try because this is just killer features. Being able to add the part so quickly and pulling all the parameters and then having an image and having such a nice category sorted database view and also inventory manager just for free, and connecting all of it to your CAD tool, be it Altium Designer or KiCAD, I think it's incredible. That's all I wanted to show you today. But before we close, if you want to say thank you for making this video, I strongly encourage you, go to the KiCAD webpage and click on donate and make a donation. It's an amazing project, and if you enjoyed watching this video, your money will be well spent funding the further development. And it's possible to sponsor the author of this repository. So if you want to use it and you want to say thank you to the author, here is how you can do it. Either monthly or one-time donation. And if you want to help me personally, you might as well visit Datasheets.md and contact me. I would give you a premium access and you can help me testing and improving the system. I want this to be a database of parts for everybody, and you would not need any skill to host your server to have your database library accessible. That is all I wanted to say today. Thank you for watching and see you in the next video. Bye bye.